Good morning. So today we are going to be learning about inverse variation, which has to do with also direct variation as well as joint variation. These three different types of relationships are all related to various different functions, and inverse variation directs it connects most directly with rational functions, which is why this is something we're learning. So I'm going to go through the notes here and let you guys try the warm-ups together and then try the last couple questions at the end. So we'll start here in the middle. First of all, this value right here is 12. In the second warm-up question, I'll let you guys try those on your own. So to determine if something is directly, inversely, or jointly related, we're basically thinking about how are things changing based on the other variable. So if you look at the amount of money you make and the number of hours you work, typically the more money you make means you worked more hours. So if both things are increasing together, then these two things are directly related. If the altitude of an airplane and the temperature of the air, if you think about as an airplane goes up into the sky, the temperature of the air is now decreasing because it gets colder as you get farther away from the earth. So in this case, the airplane is going up while the temperature is going down. So in this case, this is inversely related. And then jointly just means that there's more than one variable impacting something. So the amount of money you pay for new flooring, the quality of the flooring, and the number of square feet. Because we have three variables at play, that's going to be a jointly related situation because those variables can take lots of different forms. So that would be a jointly related situation. So the last one here, the amount you pay to rent a party room and the number of people splitting the bill. If you pay a portion of that party room, if there's more people splitting the bill, then the amount you pay would go down. So if your pay goes down, that means the number of people splitting went up. So we've got an inverse relationship again as well. So in general, direct variation is when both go up or both go down. Inverse means that one goes up while the other goes down. So basically, they both go the same way or one of them goes opposite directions. And lastly, joint is just your multivariable situation. So these three equations in the middle of the screen are going to show you how these situations are related. So this is the algebra piece that we'll use today throughout this video. So these are your three equations. Y equals k times x is going to be matched up with direct. So draw an arrow to that so you can see how y varies directly with x. If y varies inversely with x, then y equals k divided by x. And then if y varies jointly with x and w, you have the multivariable one, y equals kwx. The key to these functions is figuring out what k is. So if you go and actually find this k value, because that's kind of like a slope or something like that in the problem, by finding that value, you can then solve additional questions within the same scenario. So when we get to the algebra part a little bit later, I want you to find k, which is called the constant of proportionality. And this is also known as your slope typically in linear functions. Okay, so let's move on to the table. So quickly, let's just look at the tables. How are X and Y changing? And this will tell you if it's direct, inverse, or neither. So again, we're looking for, do both X and Y decrease or increase together, or do they go opposite directions? So if you notice in the first table, X is going down while Y is going down as well. X and Y are both decreasing. For that reason, we have a directly related variation. In the second one, X is increasing and Y is decreasing. So we have an inverse variance relationship. The second two, I think, are pretty easy to see as well. X is going up, Y is going down, so this is also inverse. And then the last one here, X is going up, Y is going up, so we have a directly related relationship. Okay, so go ahead and flip the page. We'll work through a couple algebra examples. I want to just remind you again, we're looking for this K value when we start to solve these questions. So we're going to do 3 examples on the back, and then we will be done for the day. So from a situation, you are looking for key phrases that tell you what kind of relationship you have. So if you notice, in number 1, the number of shoes made in a Nike factory varies jointly. There's your key phrase, with the number of workers and time. So the way these are set up is the Y variable is always first, and that will vary with the other 2 variables or the other variables. So the number of shoes is going to be my Y variable. The number of workers could be our W, and time can be X. Remember, varies jointly is Y equals KWX. So as you get through the equation here, you have to use the information you are given to solve for K, and then use the new equation you've created to solve for the missing variable. So if you have 20 people working for 12 hours, 600 shoes get made. The one thing I don't know yet is K. So what I can do is say our shoes equal K times 20 people working, that was W, times 12 hours. If I go ahead and solve this, I get 600 equals 240K, divide by 240, and so my K value, or my constant of proportionality, is 2.5. So this creates an equation that I can now use. My equation is Y equals 2.5 WX. Again, that's just based on this function right up here. Okay, this function relates to this here. So from now, we can take a new situation. How many shoes would 30 people make if they only had 9 hours? Well, I can plug in W and X and solve for Y to see how many shoes I make. So Y equals 2.5 times 30 times 9. And if I go ahead and type all that in my calculator, I get 675 shoes. So what I've done is kind of a 3-step process. Number 1, solve for K. K is like slope. I have to find that value to make the equation work. I write the equation, and then I use it to find anything that I don't know. And all of this stemmed from that first phrase I said, which was that this varies jointly. You'll notice in the next example, the amount of calories burned varies directly with the time that you work out. So varies directly would refer to Y equals KX. Again, going back to the chart on the first page. So again, calories burned is going to be our Y value, and time you worked out is going to be your X value. So we can start to create an equation within the example that helps us find K. Once I find K, write my equation, solve for the missing variable. So if you burn 200 calories when you work out for a half hour, how many calories do you burn when you work out for 1.5 hours? So again, 200 calories is K times 0.5 or a half an hour. If I divide both sides by 0.5, K equals 400. This translates to the equation, which is now y equals 400x. If you think about this, this is really saying you burn 400 calories for every 1 hour. So this translates into how many calories, that's y, equals 400 times 1.5 hours. This gets us to 600 calories. And lastly, we have an inverse relationship. So y varies inversely with x, which is going to tell us to use the next equation. Y equals k divided by x. Y is 20 when x is 2. There's our situation. So 20 equals k over 2. I'm going to solve this times 2 on both sides. We get 40 equals k. This makes us get our equation. Y equals 40 over x. And then what is y when x is 8? So y equals 40 over 8. So we get y equals 5. So at the end of the day, we are looking to find what is the k value that will make the situation true. That is your constant of proportionality. Once you find that, make the new equation with k in for the letter, and then use the equation with the new information to find the missing variable that you're not sure about. So please remember these 3 equations from the first page. These are super important to know, as these will guide you through the rest of the problems on the page, and they will guide you through the homework tonight. So please use this as a reference, and I will see you on Wednesday. Thank you.